Welcome back. In this lesson, we're going to talk about what a GIS is. You may have many different ideas of what a GIS is. So in this lesson, we're going to define GIS and talk about potential components of GIS. And then we'll go into questions you can ask and answer, and then the types of ways that a GIS can do that for you, and then go into just a little bit of history of where GIS came from and where we're at now. So in a more formal sense, Esri's definition of GIS is an integrated collection of computer software and data used to view and manage information about geographic places, analyze spatial relationships, and model spatial processes. A GIS provides a framework for gathering and organizing spatial data and related information so that it can be displayed and analyzed. I think that second sentence is less dense and also a really good summary on its own. And Esri is the maker of ArcGIS, so they know a fair amount about GIS. Still somewhat formal, but a little more condensed, a different definition of GIS from Burrow 1986 is a set of tools for collecting, storing, retrieving at will, transforming, and displaying spatial data from the real world for a particular set of purposes. These are still really broad if you're noticing that trend. It could be a whole lot of things. A more practical definition of GIS would be software and data that enable us to ask and answer questions involving where something is and how that location relates to other things. So I'd say if it can analyze spatial relationships or if it can display location information to you, it's probably a GIS. That includes Yelp, Google Maps, Google Earth, your GPS in your car. Anything that involves spatial information is probably a GIS. At the same time, there's no reference implementation for GIS. It's not a programming language that has a specific set of rules by which it needs to abide by. It's a really generic concept, and that's part of the power. Is it's anything. You can come up with anything related to location and relate it to data and software, and it's probably a GIS at that point. Components of GIS, potentially, are design, workflow and organization, how your data moves through it and how you analyze it, the specifications of your data or of your software, the technology involved, so that would be from the computing hardware to the software to what the user interacts with, the algorithms involved, which ties back to the workflow and the organization, and then the research that goes into it. This stuff is built on years and years of research on how computers work, on how location information is gathered and processed and used. So there are all sorts of things you should be thinking about in a GIS. And that's where you come in, is without humans to integrate all these pieces, there's no system. GIS is Geographic Information Systems. And the system is whatever we make of it. So when you put these components together, you make a GIS. And so what types of questions can we ask of a GIS? And when I talk about asking questions of a GIS, I mean that you have data that you want to learn something about. And so you can present it to your GIS and put it through an algorithm or a workflow in order to get a new result out. And that's your answer to your question. So what exists at a certain location would be the most basic question you can ask in a GIS. Just what's there? Where are certain conditions satisfied? What has changed in a place over time? What spatial patterns exist? What if this condition occurred at this place? And that's where you get into future prediction and hypothesis testing. And then where do variables interact? There are tons more questions that you can ask, but notice that location and where and spatial is a really common pattern here. That's because it's a GIS, right? So to answer those questions we're asking of the GIS, we need some information on the world. That information can fall, broadly speaking, into two buckets. There's the bucket of how it looks, that's form or pattern information, and there's the bucket of how it works, that's process information. How it looks isn't just a visual thing. It's any information you can observe about the world using instruments or vision, or that you would put down on a data sheet. How it works is different. It's what you construct, what you understand about the world based upon your observations. That knowledge of how it works is oftentimes more valuable than the information on what it looks like, because we can use that information to predict what's going to happen. So once we get into processing this data that we're collecting, there are all kinds of ways we can do it. The most basic of these is just viewing the data. And you're going to do that this week. So when you add data to ArcGIS, it displays in a viewer, and you can customize how it looks and start to understand the data just from looking at it. That's really basic, but often really critical because you can start to see errors and problems in your data right off the bat. Other ways of interacting with the GIS, other tasks you might have for using a GIS are to create new data or edit existing data because it needs to have new information attached to it, or you have corrections because of new information you've gathered. You may need to transform the data, and that's a really broad concept, but those workflows or algorithms, the geoprocessing tools, that transformation is really where you do the bulk of your asking and answering of those questions. And then when you're done with a lot of that, you're going to want to display your data to others. And that's still a big component of it, because if you learn the answer but you can't effectively convey it to others, that's a problem. So that's a large segment of ArcGIS, is just making those maps and exporting those data tables for others to see. And then finally is that you might want to integrate your systems with others on the internet in order to provide data services to people to use, so that they can pull that data into their GIS systems for use when they need it too. That's another way of sharing the data in addition to maps and data tables directly. Some basic applications in GIS that follow right onto that, end results effectively that we might see, is we're going to have cartography. We're going to make maps. We may have databases that we publish for others to use. We have topology information, which is just spatial relationships. We have long-term monitoring that we could gather and publish in the form of a database. And we can do change detection and say, what's going on in this place over time. These are just a few. There are lots of other applications of GIS, but just to give you a sense for some things you can create. The workflow that you might go through in running an analysis in GIS at a basic level is pretty simple. You're going to determine the place you're interested in and then ask that question about it and wonder. That's where you create your hypothesis. And then you analyze your data to make a map or another product like a data table, and that might require multiple iterations. You're going to explore the patterns that appear when you generate that data, and then you may decide that you need to modify your question or enhance the data in order to recreate that analysis in a better form in the future, and refine your question and get a better answer. And then repeat as necessary. Ask new questions and publish new results. Broadly speaking, there are just a couple types of GIS, but you can really construct these in a lot of different ways. But we talk about desktop GIS. That's what you're going to be using in this course. It's interactive, it's open-ended, you load data and you analyze it and you create results however you like. It's completely dependent upon the user to produce results. The server-side GIS or server GIS is usually large non-interactive servers online somewhere or in your organization where tools can be published or maps can be published and read back down, and then you can run data through those tools, but you do that from your desktop GIS. The server does the processing for you, but delivers the results back to you when it's done for use in desktop GIS. A more consumer-oriented approach would be decision support tools or WebGIS. WebGIS is stuff you've all used: Google Earth, Google Maps. ArcGIS Online is a WebGIS that's starting to blur the lines of desktop GIS and WebGIS, but they're much more oriented toward giving you results that people in desktop GIS have already created and allowing you a space to tweak parameters, play with information a little to understand something better. In the past, GIS started primarily with maps. People made maps to understand the world around them. They needed to know how to get places, and they were exploring the world and writing down what they saw. Cartography and coordinate systems predate computers by far. You've seen old maps. But was it GIS? I would say sure, because people were using maps and spatial information to understand the world around them. Formally, however, GIS didn't really begin until the 1960s with the growth of computers and a definition in a paper that was released in that time. At first, GIS was really just publishing algorithms for people to program into their own computers. There weren't just networks and computer software that people distributed. So algorithms like what can you see from here were published for others to start to program into their computers. Then as desktop computers started forming, we had command line tools that were released to run on basic systems like DOS or Linux or Unix at the time. And some of those are still around today, some of them aren't. And then desktop GIS, what you're going to be using, didn't really start until the 1990s and 2000s. It required Macintosh and Windows to develop that graphical user interface for you to look and see your data on screen in a more refined way. So that's relatively new in the history of GIS, that the workflows that we're using are possible. Today, GIS is changing pretty rapidly due to the increased computing power that we have and the widely available data that we now have. It used to be that you were data constrained and computing power constrained, and now we have lots of computing power and we have lots of data, sometimes more than we could handle. With that, we get increased data resolution, and we could construct more complex models and run larger analyses with that. We also have much more wide deployment of desktop GIS. That increased computing power is enabling the learning curve and the barrier to learning to lower, and more people can make it a part of their work. So if you're a different specialization of some sort, you may use GIS in some capacity, but it may not be the only thing you do. It's much more user-friendly than it was, but the large processing is still largely in the realm of specialists. We also have the increased use of web GIS, and it's starting to have some use in analysis, but it's mostly for displaying information to end users right now. That said, geospatial technology is an underlying framework of the internet, and you see it everywhere. And that is very mature. There are tons of products that are a part of that, though you won't learn about them in this course. So to wrap it all up, GIS is a lot of things. It can be really anything you want relating to spatial information and spatial questions and software that helps us understand that. And it can be composed of a lot of things too. It doesn't always have to have all these, but software, data, networks, workflows, procedures, people, those are all major components of what makes GIS GIS. And then geography is pretty old. GIS itself is a pretty new thing, and especially desktop GIS. And then the other takeaway would be that GIS is increasingly common. We've seen the spatial revolution with mobile phones and us carrying location devices in our pockets, and that's only going to grow as time goes on.